All right, and I made some adjustment to the course. I noticed that the dates were from last semester, so I've updated some things. And let's see, we are in module 4. I actually updated what was going on. As far as module 3 is concerned, okay, the dates were kind of, they were from last semester, right? So I sort of taken those dates out. For module 4, right, which is what we're going to start today, there's only 2 sections in this module. Today we're going to look at basic differential equations. And for the second part of this module, we're going to look at first order linear differential equations. And then I've also posted the quiz. And from this point going forward, all of the dates should be correct. The module 3 for quiz, it only covers modules 3 and modules 4, right? So it's going to cover these 5 sections. Okay, so let me kind of minimize these windows. And today we're actually going to go through just the basics of differential equations. On the home page, I posted this video, and we're going to get into this on Tuesday. Okay, but I sort of posted this short video just kind of explaining how to actually solve a first order differential equation. And what we're actually going to do today, we're going to take a look at the basics. So I'm going to go into lecture notes. And I believe this is actually in section 9.2. Okay, so here again, this was taken from a different textbook, but the information on the slide is pertinent to the course. And today we're going to look at first order linear differential equations. Okay, now we won't actually solve them, but we're going to look at the setup of a differential equation. Now, sometimes the differential equations can be first order, they can be second order, they can be third order. That's all dependent upon the order of the derivative. Okay, so in this particular instance, we're looking at a first order derivative. And in a first order linear differential equation, you should see a first derivative. Okay, so looking at the setup, and this is actually the standard form of a linear differential equation. So notice that we have dy dx, which is the first derivative. Okay, I thought I heard the question. All right, we have dy dx, which is the first derivative, plus p of xy. So p of x is actually the coefficient of our y variable. Okay, now this will make more sense once we actually get into the second session, the second module of this, the second part of module 4. Right, p of x is the coefficient, and that's equal to q of x. Right, so this is considered to be the standard form of a linear differential equation. Now, when we actually solve a linear differential equation, we use something called an integrating factor. So we figure out the integrating factor. Okay, we multiply both sides by the integrating factor, and then we integrate. Okay, we'll actually take a look at this part in the next section. You can also get a sneak peek on the video that's posted on the homepage. One thing about the solutions to these differential equations, they're a little bit different than algebraic equation. Right? When you solve an algebraic equation, you normally got a number as an answer, okay, or numbers as your answer. When you solve a differential equation, an equation is your actual solution. Okay. So here it says a number is a solution when it fits within the range of answers that the function generates. For differential equations, an equation is the solution when the equation is created that satisfies the derivative's range. Right? So keep in mind that when you solve a differential equation, an actual equation is your solution. All right, so I'm going to pull up module 4. And like if we take a look at the first couple of problems, they want us to determine the order for the following differential equations. The order is dependent upon the derivative, right? So since this has y prime plus y is equal to 9y squared, since this is the first derivative, the order here would simply be 1. If we look at the second problem, we have y triple prime plus 5y double prime, y prime is equal to 6y squared. We see that the largest derivative here is the third derivative, so that's going to give us a third order linear differential equation. All right, so the first two, we basically pull out the highest order derivative. Now for problems 3 through 8, they are slightly different in that we'll take a look at problem number 3. Right, for problem number 3, it says that the solution of a certain differential equation is in this form, right? So this is the actual solution. Where a and b are constants, the solution has an initial condition of y of 0 is equal to 4, and y prime of 0 is equal to 2. And we have to find a solution by using the initial condition to get the linear equations for a and b. Okay, so some of the problems are such as this, and then we have other problems in which you basically want to find C. All right, so taking on just a visual look at problem number 4, right, you're given a first order differential equation, y prime plus 2y is equal to e to the negative x. We're also given a solution. We're given an initial condition, and then we're asked to find C. Right, so we're going to take a look at problems similar to number 3 and for number 4. Right. But before we begin, I want to take a look at some review material. I'm actually want to go back and take a look at the derivative review for exponential e. All right, because we will be taking the derivative of exponential e. All right, and this is basically what we're looking at. It says if u is any differentiable function of x, then the derivative with respect to x for EU, that's equal to EU times du dx. All right, and we're going to take a look at an example. So I'm going to bring up OneNote. So let's say we want to find a derivative with respect to x for I'm going to use t because the variables we're going to use in our problems for t. The derivative with respect to t for e to the 7t, right? So here's what the formula says. It says that the derivative with respect to EU that's equal to e raised to the power of u times du by dx, right? So what this means is when we take the derivative with respect to x for e to the u, it's going to return the original exponential times the derivative of the exponent. All right. Just slide this over. So if we want to take the derivative with respect to t for e to the 7t, right? It's going to return the given exponential, so it's going to return e to the 7t times the derivative of the exponent. So the derivative with respect to t for 7t, right, that's going to give us 7. So my derivative here is 7e to the 7t. All right. So we're going to take a look at another example. The derivative with respect to t for e to the 10t, right? It's going to return the exponential given, so it's going to return e to the 10t times the derivative of the exponent, right? If we were to take the derivative for 10t with respect to t, it would return 10. So here we have 10e to the 10t. All right, so I wanted to review that before we actually begin. All right, so now we're going to take a look at a problem, and I'm actually going to write this one out. So it says the solution of a certain differential equation is of the form y sub t is equal to a times e to the 7t plus b e to the 10t, right? So that's the given solution to the differential equation. The solution has initial conditions y of 0 is equal to 2, excuse me, y of 0 is equal to 4, and y prime of 0 is equal to 1, right? So those are the given initial conditions. And we're asked to find the solutions by using the initial condition or initial conditions to get linear equations for A and B. Okay, so I'll give you a second to copy that down. All right, so notice that we're given y of t is equal to ae to the 7t plus be to the 10t. We're given y sub 0 is equal to 4, and then we're also given y prime is equal to 1. All right, so here are the steps. What we're actually going to do is we're going to find A and we're going to find B. All right, and we're going to do that in a couple of steps. All right, so here is the first step. We want to use the first initial condition and substitute into the given equation. All right, so here's what that's going to look like. I'm going to take that initial, I'm going to take the given equation, which is y of t is equal to ae to the 7t plus be to the 10t, and I'm going to substitute y of 0 is equal to 4. So now how do we solve y of 0 equal to 4 into the given equation? Well, we're going to substitute y for 4, right? And we're going to substitute t for 0. All right, so right inside we have y sub t is 4. That's equal to a times e to the 7 times 0, right? Because I'm substituting t for 0, plus b times e raised to the 10 times 0. So if I simplify my exponents, we have 4 is equal to a times e to the 0 plus b times e to the 0. So keep in mind that as a fact, e to the 0 is equal to 1. All right. The 0 exponent rule says anything raised to the 0 power is 1. So we have the equation 4 is equal to a plus b. All right. So I'm going to circle that. Okay, now the next thing we're going to do, right, notice we're given a second initial condition, y prime of 0 is equal to 1. But our given solution is just y. So what we're going to do is we're going to take y of t, we're going to find the derivative, and then we're going to substitute in that given initial condition. All right, so our second step, we have to find y prime and then substitute the second initial condition. All right, so I'm going to write out y of t, right, which is what we're given. That's equal to a times e to the 7t plus b times e to the 10t, right? And we want to find the derivative. So I want the derivative with respect to t for ae to the 7t plus the derivative with respect to t for be to the 10t. Now keep in mind that a and b are constants, right? So we can pull constants in front of the derivative operator. Right, so for my first term, I'm going to pull a in front of that derivative operator. I'm also going to pull b in front of the second derivative operator. All right. So now we need to take the derivative for e to the 7t and the derivative for e to the 10t, right, which we found earlier. So when we take the derivative for e to the 7t, we actually get 7e to the 7t. So that's going to equal to 7a e to the 7t plus 10b times e to the 10t. Right? And that should be y prime of t. Now, since we have y prime, we're going to substitute in the second initial condition, which is y prime of 0 is equal to 1. So here again, we're going to substitute 1 for y prime of t, and we're going to substitute 0 for t. All right, so substituting in, we have y prime of t, that's equal to 1. That's equal to 7a times e to the 7 times 0 plus 10b times e raised to the 10 times 0. I'm going to simplify, so we have 1 is equal to 7a plus 10b. All right, so if I kind of shrink in on this a little bit, notice that we have two equations. We have 4 is equal to a plus b, and 1 is equal to 7a plus 10b. From this point, we're going to solve the system of equations, and we're going to figure out a and b, and then we're going to substitute a and b back into the solution for the differential equation. All right, so our third step is we want to solve the system. So we're going to look at solving the system in a couple ways. We're going to look at it by hand, right? We're going to use substitution, the substitution method. And then we'll also take a look at the calculator. All right, so we're going to solve the system. So our system of equations is a plus b is equal to 4, and 7a plus 10b is equal to 1. All right, so we have our first equation and our second equation. So in this case, I'm going to use the substitution method. So I'm going to take the first equation and I'm going to solve it for a, right? So I'm simply going to subtract b from both sides, right? Remember, when you're using the substitution method to solve a system, you must take one of the equations and solve it for one of its variables. So I'm simply taking the first equation and I'm solving it for a. Right, so in order to solve for a, I would subtract b from both sides. So I have a is equal to 4 minus b. And then once we solve one of the equations for one of its variables, we must then substitute the newfound variable into the other equation. Right. So I'm going to do that here. So I have 7a plus 10b is equal to 1, and I'm going to substitute in a is equal to 4 minus b. Right, so we have 7 times a, which is 4 minus b, plus 10b is equal to 1. I'm going to distribute 7. So we have 28 minus 7b plus 10b is equal to 1. I'm going to combine like terms. 28 plus 3b is equal to 1. I'm going to subtract 28 from both sides. So we have 3b is equal to negative 27. I'm going to divide both sides by 3. So b is equal to negative 9. Right, so we found the b coefficient. Okay. Now, in order to find a, so I guess I should list this here. What we did here was we were able to find b. Now I'm going to find a. So in order to find a, we need to take the result from the previous result, which is b is equal to negative 9, and we need to substitute that into either one of our two original equations. Right, so I'm going to take that first equation, a plus b is equal to 4, and I'm going to substitute b for negative 9. Right, so I have a minus 9 is equal to 4. Add 9 to both sides, so a is equal to 13. Okay. So now that we have the coefficients a and b, we can simply substitute those into our solution. All right, so we have y sub t is equal to 13e to the 7t minus 9e to the 10t. All right, so this is our solution. All right, now I also want to show, I'm going to go back down here for a second, how we can actually solve this system by using the calculator. So I'm going to bring up the calculator. All right, I'm going to bring up the calculator. And if I'm going a bit fast on this, I will put a video up on how to solve a system by using the calculator. So the first thing I want to do is enter this matrix into the calculator. So I'm going to go into matrix. So that's second and matrix. I want to scroll over to edit, right? And I want to edit matrix A. So I'm going to hit enter. Now, whenever you put in a matrix, you have to put in the dimensions, and the dimensions of a matrix are denoted by its rows and then its columns. So looking at our system of equation, it has 2 rows, right? This is the first row, the second row, and then we have 3 columns. This is our first column, our second column, and our third column. Right, so this matrix is a 2 by 3. So I'm going to put in rows first, which you must do. I'm going to hit enter, and then I'm going to put in the number of columns, which is 3. So we have a 2 by 3 matrix. Next, I'm going to put in the coefficients, right? So the coefficient for A is 1, the coefficient for B is 1, and then the coefficient for 4 is 4. So I'm going to put in 1, enter, 1, enter, and 4, enter. I'm going to put in the coefficients for our second row, which are 7, 10, and 1. Right. From this point, we have our matrix entered into the calculator, and I'm going to go back to the home screen. So I'm going to use second and mode, which is the quick key. Now, in order to calculate up the coefficients, I'm going to go back into the matrix. So I'm going to hit second and matrix. I want to scroll over to math. I want to scroll down to RREF. So notice you see an REF, but we want RREF, which is reduced row echelon form. So I'm going to hit RREF. I'm going to go back into the matrix. I'm going to input matrix A. So I'm simply going to hit enter. I'm going to close off the RREF function, and I'm going to hit enter. Right, so what we have here are actually the solutions, right? So the way we put it in is really the way that you read it. So the first column, it represents A. The second column represents B, and the third column represents what our matrix is actually equal to, or what our equation is equal to. So if we look at this first equation, or the first row, it's actually read as 1A plus 0B is equal to 13. All right, so which is the same thing as A is equal to 13. If you look at your second row, it says 0A plus 1B is equal to -9, which is the same as B is equal to -9. All right, so this is another way to pull out the A and B coefficients. Okay. So you may be familiar with that, you may not be familiar with that, but I will post a video on the announcements page, our home page, kind of going through that same process. All right, so you will encounter problems such as these, and you will have to solve a system of equations. All right, now we're going to take a look at the second type of problem that we're dealing with in this section. Let me just slide my calculator to the side. All right, so for this example, we're given that y is equal to x squared plus c divided by x squared, and that is a solution of the equation xy prime plus 2y is equal to 4x squared, where x is greater than 0. All right, so what we're given here is we're given a first order linear differential equation, and we're given the solution. All right. We're asked to find the value of c which the solution satisfies the initial condition y of 10 is equal to 2. So in this case, we're given the linear differential equation. We're also given its solution, right? And we're asked to find c. So just like we did in the previous example, we're going to take that solution, y is equal to x squared plus c divided by x squared. We're going to substitute in the initial condition, and we're going to solve it for c. So we're going to substitute the initial condition into the solution. Okay, so when I mean solution, a solution of a differential equation is an equation. So to actually write that out, I'm going to write this out as y is equal to x squared plus c divided by x squared, and we're going to substitute in y of 10 is equal to 2. Right, so keep in mind that we're going to substitute y for 2, we're going to substitute x for 10, and we're going to solve it for c. So y, which is 2, that's equal to x squared, so we're going to substitute x for 10 plus c over 10 squared. All right, so 10 squared is 100, so we have 2 is equal to 100 plus c divided by 100. Now we're going to solve for c. So the first thing I'm going to do in order to solve for c is I'm going to subtract 100 from both sides. So I have negative 98 is equal to c over 100. I'm now going to multiply both sides by 100. So I have negative 9800 is equal to c. All right, so our solution for c is negative 9,800. All right, so at this point, all right, I'm actually going to stop the